Okay, I see people are joining. Maybe we'll give them 1 or 2 minutes. Okay. We have about 28 people, 29 people have joined. Okay. Hello, everyone. Good morning, good afternoon, everyone from wherever you are attending this webinar. Welcome to our first GeoHealth webinar in 2023. My name is Azar Abadi, and I will be your host for this event. Today, we have the pleasure of having Dr. Robbie Parks. He will be sharing his expertise and insights on utilizing spatiotemporal data for climate-related health studies. Dr. Parks is an environmental epidemiologist and an assistant professor at Columbia University in environmental health sciences. Dr. Parks has diverse experience in large-scale multidisciplinary quantitative research focused on climate-related exposures and public health. He's currently an NIHS K99 fellow at Columbia University. He is also a fellow in the Agents of Change in Environmental Justice program. Before we begin, please make sure you have your microphone and camera off during presentation. This webinar is recorded, and the recording will be posted in the GeoHealth YouTube channel. I also encourage you to use the chat feature to ask your questions. After Dr. Park's presentation, we will have 10 to 15 minutes for Q&A from the general audience, and at 2 p.m. or 3 p.m. Eastern Time, I will hand it over to early career folks to host the early career development Q&A section. Once again, thank you for joining us today. And now, without further ado, I would like to formally introduce our speaker, Dr. Parks. The floor is yours.
Thank you so much, Azar. And yeah, thank you for that very fantastic introduction. I should say I officially start April the 1st. So I look forward to starting as assistant professor. Until then, I'm working as a postdoc, and then yeah, look forward to the next stage of my role at Columbia Mailman School of Public Health. So today, yeah, it's going to be a sort of mix of thanks for AGU GeoHealth for the opportunity to present also. So really, it's just going to be a sort of overview of some previous work I've done, some sort of future directions, but also just a little bit of a sort of overview about how I think about sort of establishing studies and actually sort of figuring out what is possible to do potentially with kind of climate related exposures and public health, because obviously I think probably a couple of years ago, 3 years ago, I would say it was a growing subject, but now I think it's in some ways a grown subject. It's a sort of almost mature subject now. So so it's really good to see that. And so again, I'll just quickly go through the outline really. So climate related exposures and health, climate related health studies, other related work, some conclusions, and some future directions. But I like to start these things just with a little bit of a human side about me. Just I'm a real human being, so and so on my professional side, a sort of mission statement, if you like, is uncovering hidden burdens of climate related exposures and health, including how health is impacted by climate related exposures, who is impacted, and what needs to be done for positive change. I sort of see the remit of academia now as having grown to incorporate beyond just sort of I guess publishing papers to actually having missions, and I think at my university, Columbia, it emphasizes that as well as I'm sure many other universities do too. So And I sort of see these research focuses, one of course being climate and health. And yeah, like as I said, from April, I'm going to be sort of starting my lab, and of course looking for collaborators and for people who are interested in working with me too. So excited about that. And just as a personal background, here's me with my parents and my sister. I grew up in London. I'm from a mixed racial background, first generation university student. And so why am I telling you this? I think I'm just telling you this because, I want to feel like I'm approachable, but also that, there are opportunities for everyone to be included. And I believe that in that strongly, in the idea that everyone should feel included in our field. Recently, I was at COP27 as an official observer. So, in terms of climate change policy, that was a real education, even though I was sort of at the bottom of the food chain there with regards to being an official observer rather than a negotiator. And I'd have a whole hour or two presentation about that as well. But as I said, also, I am a current Agents of Change fellow. And the Agents of Change is a great organization in environmental justice, I should say, Agents of Change in Environmental Justice, which examines and looks for fellows who are interested in developing their careers from, lots of different backgrounds, a variety of diverse backgrounds. So it's well worth checking out. And so as part of that, we produce a podcast and interviews and a personal essay. So I found that really exciting. So just wanted to shout out for that.
My place even wasn't there.
I think I can hear someone, but I'll carry on. So first of all, what are climate-related exposures and how do they impact health? So I find this overview of Lancet Countdown useful. You got emissions and pollutants, from climate-related emissions, and that causes climate-related phenomena, such as raised temperatures, extreme weather, hurricanes, cyclones, particulate matter, air pollution, others you can see here. And this in turn affects some climate-related exposures, heat waves, droughts, fires, and impacts societally relevant phenomena such as ozone increase, particulate pollution, and eventually having health outcomes along the bottom here. And you can see a variety of different causes, and you can go into as much detail as you want with those particular causes, but those are sort of maybe useful broad groups at the bottom. Now, of course, climate change and public health is a social problem as well. It's a social issue, and so socio-economic mediating factors are also important: poverty, racism, loss of habitation, violent conflict, and other social determinants of health. So, but I think just to say that there's lots of lots more research, I believe, that could be done for the good of the field. And from an American perspective, from a public health perspective, last year there was a huge announcement of lots of funding from essentially originally from the Biden administration, but via the NIH of $100 million, if I remember correctly, for climate change and public health research, specifically filtered through a public health lens. So for all of you who want to collaborate or want to work in the space, I think it's a good time from a purely research perspective. Probably wish the problem wasn't there, but it is. And so just a snippet from the conceptual framework, from the way the NIH is thinking in terms of climate drivers, exposure pathways, and health outcomes, and how. So it's just another way of looking at that Lancet countdown diagram in an informative way. And of course, details of connections are part of the research that we would propose via grant submissions, etc. Now, for the Lancet countdown was just released, over time, countries recognizing climate change and of course public health has been a very important component of many different countries associated in the UN for over time. But the intersection of climate and health, as you can see from the end with this sort of gray intersection bar, is getting higher and higher. So the recognition from the state level is also increasing. And so while I'm focusing mainly on the United States in my talk, I do talk about the need, for studies which are directly in places which are at frontline communities, really, be it in the United States or worldwide. So why do we still study all this? Well, of course, climate change is bad. I think anyone who's probably on this call appreciates that. And, we need to sort of mitigate and adapt. So I would say, it's still important why we don't focus just all our research concerns on the political change, such as COP and other intergovernmental sort of concerns and national concerns. There are many understudied health outcomes, I would say, including mental health related outcomes that, we need to understand better. Understudied exposures in particular, you could argue tropical cyclones is growing as a concern in public health space. Of course, it's been a concern for society for as long as we can remember, but in terms of public health, humid heat, for example, wildfires, the short to long-term impacts on public health and quality of life. And other than informing regulations, as like the EPA and air pollution has been a classic example of success at how the correct research can inform limits, legal limits to air pollution. But other than informing regulations, what else can we do? Well, I think we could take the front foot with research, for example, identifying vulnerable communities and producing targeted interventions in consultation with policy experts so that we understand what can actually be done rather than just describing what is to be done. Now, of course, this is a huge problem locally, but also globally in the United States, but also the rest of the world. I assume most of the audience is in the United States today. So, but of course, the worst impacts are on the poorest and least resilient communities in the United States and worldwide. So, hope you agree. Still, plenty of work to do. Now, with regards to you want to do, okay, so you're interested in climate change and public health, and you're sort of, well, what do I do? I mean, that's the sort of the essential question that I suppose you probably would go through in your PhD and beyond. But if you're sort of crossing over to disciplines and want to collaborate, then first of all, it's a very strong recommendation to collaborate with public health experts if you're, say, in geoscience as well. But of course, these are the essential components probably that I ask myself before I start any study, but maybe even before I have anything. Is first of all, what is the research question? So it's when I think a lot of there's so much data in the world, and it's very easy to sort of have a data first approach, but really what is the research question is probably the most important component. Now, I do appreciate that, of course, that is linked to the data availability there. So research question is probably informed by data availability, but in the context of climate related exposures and health, what is the exposure, or what are the exposures? What is the particular health outcome we're interested in? What's the basis and plausibility of studying the links, and what is your hypothesis, or what are your hypotheses? Then, of course, these two are sort of linked, as I said. What kind of data do we actually have? So are we thinking of a study which would be nice to have in the next 5 to 10 years, or do we need to do it in the next year? And are we looking to do it in terms of a pilot study that gets greater funding, or are we actually doing it as a PhD project? These kind of timescales are important as well in the real world of academia, of course. So what kind of data do you have? The types of records, are they death records? Are they hospitalization records? Are they survey records? What's the time resolution? What's the spatial resolution? Do we have similarity between neighboring units, such as age groups? Or can we do some kind of spatial smoothing over space and across age groups as well? Do we care about gender? And do we care about, sort of socioeconomic status? Well, of course we do, but in the context of the research question. And what's our coverage over space and time? Those are important questions to ask oneself when going into sort of creating an analysis. And of course, are there any other considerations? Well, are there other things that could potentially have an association? Could be effect modifiers or mediators or confounders in the study. Do we assume that there's a linear exposure response curve, because linearity is an assumption, of course, between, say, the rate of cardiovascular disease, deaths, and air pollution, for example. Is that linear, or is that log linear, or is it not just plain old non-linear? And especially with Bayesian computing, what are the computing resources that will enable you to do these large-scale studies? And also, how sensitive are the data sets? Is probably another thing I would think about, and that's particularly true with public health. So those of you who may be new to sort of using public health data, that's definitely a consideration. And of course, the important thing for that is collaboration is key. I mean, that's an essential tenet of all of research, but particularly with when dealing with having to learn the sort of Byzantine at times nature of the way that public health data sets are dealt with good reason, of course, but you know, it's not necessarily clear at all times. Which brings me to my next point. Always get IRB consultation and approval or exemption. Now, IRB is basically the process you go through when dealing with data that is sensitive to human subjects or animals, where you need to sort of get ethics and have someone to look through it and approach it. And so you have this kind of, can you see? Sorry. Yeah, so what you can see here is, sorry, I think my screen is just, if my screen isn't showing anymore, then just please let me know. But I think it is, because I haven't heard from anyone, but please let me know if that's not the case. So here you could see a guide whereby, you know, you sort of think of a project like in the data and everything, then, you know, is my project research? Now, of course, your project is research most of the time in our field. And so does it involve human subjects? Now, it's yes or no, but sometimes you may think it's no, and then that's fine. Or you may think it's yes, but it's exempt. And so it's always worth understanding that before you actually do the work or publish the work at least. And so collaboration again is key there. And just as a few sort of guides, you know, the links at the bottom here would probably help you decide whether it's human subjects research, which you need to take a special careful approach with that and get permission from an IRB. Also, you need to, you know, if in doubt, just ask someone at your local IRB office. And that's the one we have on our Columbia website. So assuming I haven't heard anyone say that they can't see the screen anymore, I'm going to carry on because I still can. And so back to this diagram.
You're good,
I'm good. Okay. Yeah, thanks. So just back to this diagram, of course. Now I'm going to start with air pollution just because I wanted to show, you know, more in detail, probably an example, a slightly older example of utilizing spatiotemporal data in the United States with air pollution. Just and then I'll go through other studies, but so, I know in terms of climate-related exposures, you know, air pollution is one of those, but it's not necessarily the first one you think of. But I'm going to start with them. So you see other air pollutants and cardiovascular respiratory disease. So the question we asked ourselves in this study was, what's the relation between the particulate matter and air pollution? And it was PM2.5 in this case. And so here was what we had available for a study population. We had 18.4 million cardiorespiratory deaths in sort of a decade and a half or so for the entire contiguous United States, but that was by county. So it's by county, and the minimum resolution was by month. So for long-term air pollution studies, you would sort of look at annual death rates. And so we looked at annual county level cardiorespiratory death counts by principal cause of death diagnosis, and it was balanced by the population estimates of each county in that time. So you see, there's a lot of data collection here already, which involves trying to understand whether you're IRB exempt, whether it's human research. It looks like it's human research, but it is in this case exempt under number 4, exempt reason 4 in this case. So you could look in more detail about that. But you know, a large part of my PhD and beyond is a lot of it is sort of understanding the structure of the data and what's available. And so if you're thinking about, you know, trying to understand spatiotemporal data in the context of you know, climate and public health studies, this was by county and by year. And so for exposure, we had annual mean PM2.5 available here, and you can see a map which I'll go into detail in the next slide. And you know, for those interested, it was a land use regression model to associate the observations in a universal Kriging framework done by Cases and colleagues Carnegie Mellon University. And so just as a brief examination of the the actual data, so just looking at PM2.5 concentration, it ranged from 2.8 micrograms per meters cubed in Arizona to 13.2, the annual average. And of course, since then it's gone sort of down, then up, then down again. And you could see there's large variation from this histogram of county level annual values in 2015. We're largely below the at the time national ambient air quality annual average for particulate pollution, 12, apart from 4 counties. So this was a good news story really in 2015. Although it got slightly worse, then it got better again. It's still a good news story, which is one of the successes of policy, really, air pollution in the United States. So those are the exceptions. And so the next map shows, where the largest, in previously most polluted counties, the more purple it is, the greater reduction. It can be seen that, in Southern California, in the next plot, where, that the largest, that had the original highest pollution level, but then it had reduced by the greatest. And so you could see that in another way in this next plot, where you see on the x-axis was PM2.5 level in 1999, and PM2.5 on the y-axis reduction during the study period. You see the greater the original value, the greater the decrease in general, as you can see from the positive correlation, really, if you like. So again, good news stories, but not everything has gone down to the lowest value here in that time period. So of course there is work to do there. So then the next question is, you've got the data. Describe the health data a little bit, and now I'm going to go into the statistical model. So we wanted to know the association between annual cardiorespiratory death rates at PM2.5 using a Bayesian spatiotemporal model with +1 counts, leveraging variation of a space and time to infer associations. We quantified associations with our unit of change being a death rate ratio per 10 micrograms per meters cubed, and adjusted for longer term time trends, county specific effects. Now you can see, in terms of equation form, this is the model that was used to generate the figures that you're about to see. And so for each age group, it was an age stratified model. We did it, by age group, so that we can calculate life expectancy via something called a life table. And you can see all the different components which I described in the previous slide, and I'll just skip ahead here. So, the first result is aimed to show how much the lowering of PM2.5 in the US over the 17 years of study had contributed to life expectancy. And you could see from the legend below that we're looking at how much has improved from the lowering of PM2.5. So the first result is for females, and reduction in pollution has benefited most of the country because it's all in green, with the exception of 14 counties where PM2.5 increased slightly. And you may sort of wonder why, and we could talk about wildfires going, increasing, actually driving increases in the Pacific Northwest. And so the overall life expectancy increase from PM2.5 was 0.17 years for females and 0.15 for males, sorry. And that may be a somewhat abstract number, but for females in this context, the total increase in life expectancy during this time was 2 years. So the increase in life expectancy on average from PM2.5, if you believe to be causal, with lots of work, sort of shows, more and more one of the most studied associations between death rates and pollution, showing this to be what they believe, really. And so that represents 10% of the total increase was due to the reduction of life expectancy. So to put it another way, around 10% of the gain could be attributed to reduction in PM2.5. But you can see, of course, that the gain is unequal between, say, for example, those two circles. And of course, the inequality of life expectancy loss can be, so we can alternatively express this by trying to understand how much life expectancy has been lost by not reducing PM2.5 to nationally minimum levels in 2015. And so just as a preview, really, you can see that if you take each county and you say it's how much above the lowest national value, say the lowest national value was 2.8 in 2015, 2.8 micrograms, how much above that was each county, and therefore how much life expectancy gain had not happened yet. And you see, so life expectancy loss is the life expectancy that hasn't happened yet. And so what you're seeing is the further the PM2.5 exceedance, the greater the life expectancy loss. But we've also colored the counties by, the income. And what you can see is actually for the same PM2.5 exceedance, life expectancy loss, if you draw a sort of straight line and compare these two circles, richer counties are losing less life expectancy for the same PM2.5 exceedance than poorer counties. Now, of course, that's a matter for environmental justice, and it's a function of the different vulnerability, but also the different baseline death rates of those counties. So nonetheless, the burden is sort of greater on poorer counties there for life expectancy loss. So, and you can see that for male and female, it's similar. Now, for back to this diagram, we can see extreme weather, which tropical cyclones fall under, which I'm going to talk about now, tropical cyclones. So we're talking about which of these health outcomes were impacted by cyclones. And so that was our next research question, which I'll go into. I just wanted to say, the PM2.5, the papers that they're all out there, which I'm talking about now, or most of them anyway. And so, we can talk about in detail the models, etc. But I just wanted to give you an overview of what different approaches and different data availability can give you with regards to studies for those of you who are interested. So first of all, what is a tropical cyclone? Well, maybe many of you know, but for those that you don't know, cyclones such as hurricanes and storms are intense circular storms that originate over warm oceans and are characterized by low atmospheric pressure and high winds. And that's said as someone who's an environmental epidemiologist, so I hope I haven't changed that too much. But they they draw energy from the sea and maintain strength as long as they remain over warm water. And when they make landfall, they're obviously extremely destructive and very live long for a long time in the memory of people experience them in the United States and worldwide. And so, for example, just a few recent examples, Hurricane Ian here, that was just last year, and you can see buildings and death tolls are high. And it's not just in the United States, of course, in some ways it's much worse elsewhere. So Philippines, recent typhoons there have sort of caused all sorts of havoc, and the long shadow of the cyclones really is an issue for public health. So as a sort of approach, I just show you what our aims were. Therefore, given what we had from a previous paper out just under 2 years ago now. So to characterize the impact of cyclone exposure on hospitalizations from various causes in the United States in an older population, because we actually had Medicare hospitalizations available from our colleagues nationally, but of course cyclones hit not nationally, but a subset of the United States, and I'll show you in a second how that manifested. And we also wanted to identify, these are our research questions and therefore generated our aims. And so that's a general approach to these kind of studies, is to have a hypothesis and then see what you think might happen. So identify effect modification by classification of cyclone and type of hospitalization. So our study population in this case was 70 million Medicare hospitalizations from 1999 to 2014 in around 900 counties in this case. And you could see the total hospitalizations on the right, and the colors are causes, which we'll come to in a second. And we use sort of ICD-9 codes. Now, if you're doing specific causes, you'll often see ICD codes, so something to keep in mind. But they, awkwardly for our kind of studies, they shift from 8, 9, and 10 over the last few decades, and so they completely change. And that's another challenge of dealing with health data here for the purposes of climate-related studies. We divided them using 13 mutually exclusive and clinically meaningful causes that you could see on the bottom. And we also did an exposure assessment for tropical cyclones. Now, Brooke Anderson, Colorado State University, generated a fantastic data set, hurricane exposure, which are our package, and hurricane exposure data. And so we collaborated for this study, which really, for epidemiologists especially, you want to do a study, but really it's actually an interesting point for most people who are interested in exposure assessment. For public health, you really need units that are meaningful for public health units, because you don't necessarily get exactly where people live, but you may get the county that they live in or the zip code that they live in. Now, there's challenges with zip codes changing, etc. But Brooke made a data set which we could use, which was designed specifically for health studies, so that it was by county. So that was extremely helpful. And we divided it into just tropical cyclones and hurricane force winds for those tropical cyclones as well. Now, so I'll just give you a sort of preview of some of the results there, just to show what we did and what could be done with this kind of setup. So we analyzed the percentage change in hospitalization rates associated with cyclone exposure. So to the right of 0 is an increase, and to the left a decrease. And we did this by days after tropical cyclone exposure, up to 7 days after day of exposure. So on the y-axis, 0 is the day of exposure, on this down to 7 days after cyclone exposure. So I'm just going to highlight a couple of examples. So first, respiratory diseases, we observed the highest overall increases in hospitalization rates for respiratory diseases, and they occurred generally across all study days after the day of exposure, including a maximum 1 day after, so about 24%. And so, just in terms of the plausibility of results, power cuts are a huge sort of issue after tropical cyclones, and the idea that people need breathing and medical equipment, and people with existing conditions, which may compel them to visit hospital if the power fails, for example. But there's also other things like dust being kicked up and things like that. Now, maybe unsurprisingly, also, of course, injuries is another, particularly clear example here, where the increase was 2 days generally after cyclone exposure. Now, but the rest of the 13 typology is really these 3 typologies: cardiovascular diseases. We observed decreased hospitalization rates on the day of exposure, peaking 2 days after, and gradually returning to the rate expected within about a week. Now, other causes tend to follow the same pattern, but does that mean, hurricanes and cyclones are good for you? No, remember, this is hospitalization. So there are behavioral elements at play, which are, other considerations to take into account if it's not, for example, death. And of course, death can happen longer after. So really, these 11 causes had a similar typology to cardiovascular diseases when we studied these in relation to hurricanes. Now, we studied over 100 subcauses as well. So cardiovascular diseases is a large group. And you see now instead we've got the x-axis percentage change in hospitalization rates, and on average in the week after, and on the y-axis you've got causes. So I'm just going to take an example to talk through here. So cardiovascular diseases integrated over the week didn't actually change, but there was variation in changes to rates for the subcauses. For example, here you could see, acute myocardial infarction or heart attacks, if you like, highlighted here. Where in contrast, you got heart valve disorders in decreases. Now, of course, the broad dichotomy here, there's some exceptions, very, very few, where non-emergency or chronic hospitalization rates went down and emergency or acute went up. So I'm not going to look at all the subcauses in the interest of time, but they are all there. And so we were also interested in okay, so these got papers of the month, whatever, but then of the decrease in the hospitalizations, we then thought, well, what do we have for mortality data that we could think of? Because the decreases aren't that convincing in terms of, do we think that they're good for your health? We do not actually. So then we decided to look at mortality. So that was our next study. So in this paper released last year in JAMA, we looked at cyclones and hurricanes across the United States for the past few decades, since 1988. And just give you a preview of results without talking about the methods again, because it's by county, it's by month this time. Remember, it's by year for air pollution, and it was by day for tropical cyclones. So these things matter with regards to model building. So in this case, we're interested in the difference between hurricane force and just gale to violent storm plus for tropical cyclones. And we're looking at months after. So we're more looking at sort of the mid to long term effect, so association on death rates after hurricanes and cyclones. So on the y-axis, you've got percentage change. And so, for injuries, you see this on the month of and month after, this huge sort of spike and a gradual decrease, much stronger, but similar in shape to the tropical cyclone, force winds. So that's the sort of headline figure, I suppose, the difference between those. But we did it by 6 broad causes of death, and you can see the negative control for cancers really is reassuringly there's no change. Well, not reassuringly, I choose my words carefully, but in some ways it acted as a negative control. But you did get increases in cardiovascular diseases, infectious parasitic diseases, neuropsychiatric conditions, and respiratory diseases. Now, you could probably spend a whole paper or a whole talk going on about specifically each cause or each sub-cause of that, but that's just a preview. Now, of course, the study design with these kind of data relevant to spatiotemporal data are, do you have it by particular groups or subgroups? And so we did it by age group in this case. Now, just to highlight one benefit, that including more than just Medicare, which is usually 65 plus, but the whole spectrum, as you could see that, for injuries in the first couple of months afterwards, there was an increase for 65 plus, which is larger than the younger ages, which isn't necessarily surprising. But the fact that there is an increase in younger ages sort of speaks to maybe that hidden burden, if you like, of if you choose to look in a certain place, you'll find probably what you're looking for. But then you take a step back, is there more to look at? And that's sort of 0 to 64 too. It's worth asking those questions. And relevant to that, of course, tropical cyclones affect other places in the world. And so, recently, environmental health perspective, we sort of talked about how important it was to look at worldwide. And I know there's lots of really exciting studies going on sort of worldwide, and I'm very happy that that's happening. Particularly, for me personally, the Philippines. So I wrote this in partnership with Renzo Guinto, who's a physician in the Philippines. And this is sort of the statement I would sort of think about there with regards to new studies that can be done in partnership with the people in those countries, or if you're in those countries or have some connection with that country too, to think about those places like the Philippines, other frontline countries with regards to cyclones and other climate related disasters. So, here's a quote, I'd sort of said, radical progress in my field means, accurately quantifying climate change health impacts, not just where it's easiest to look. And so just in terms of the time I've probably got about 5, 6, 7 minutes left. I'll just go into temperature as an exposure. And so back to this diagram again, you could see, impacts on mental health. This is just but an example of one of the things which you may decide to look at with temperature. Now, there's temperature is one of those exposures like pollution, which people have looked at for a reasonable amount of time now with respect to climate related exposures and public health. But I still think there's lots to do. And so like with air pollution, people are still spending their whole careers on it. I think with temperature you could do that. I think there's a whole opportunity base there for people who are thinking of trying to move into climate related exposure to public health here, particularly say with mental health outcomes. Now, of course, I mentioned that data is important. Data is everything, and reliable data, of course, is everything with respect to these kind of studies. So, for example, the Oregon State University have a really great PRISM data set. I found myself constantly summarizing those data, those raster files into shape files that meant something for public health. And so, if interested for people, that I spent some time converting those PRISM grids into FIPS, zip codes, and census tracts in the United States. And so you can see the GitHub link there. And please let me know if you're interested in sort of collaborating, whatever, or on those. But in general, just to highlight that that's typically a process that you need to think about. You may actually have the exact long and lat of their house as well. But you know, for spatiotemporal models, often with regards to sensitive data, you might just get the sort of geography, the broad geography that they're in. For example, in New York State, you know, by zip code here, you've got average temperature, you know, that sort of varies. But in this case, we also had spatiotemporal data for alcohol-related disorders and substance-related disorders across New York State for the past few decades too. And, you know, just on the sort of broad highlight of different ways you can model exposure response. In this case, you know, using distributed lag nonlinear models, you may generate nonlinear. It doesn't need to be linear by default. It may end up suggesting that it should be linear, but not necessarily by default. But here you get an exposure response for alcohol-related disorders and substance-related disorders that are decidedly proto-linear than nonlinear. And so those are kind of different ways you can look at it. Now, of course, because you got spatiotemporal data, you can look at it as an effect modifier by space. So here, you know, because I'm in New York City, maybe I did New York City and the rest of the New York State, but you could do it by other things here too, to look at the sensitivity of alcohol-related disorders in relation to temperature and by substance there too. And so you may see some changes or potential differences in the higher temperatures between New York City and not New York City, and you can go into a discussion about why that is. So other mental health related studies that I think were important, you know, for assault and suicide in particular, looking at it by age group, thinking about your study design to think of it by what you're actually trying to find. Now, we tried to find additional, you know, an estimate, say, per degree of anomalous temperature, what would happen to by age group and by sex here for intentional and unintentional injuries. Now here, just briefly, we found that the large bulk of estimated additional deaths from intentional and unintentional injuries, that's transport falls, drownings, assaults and suicides, were concentrated in younger males. So, you know, that's I think that was a very interesting result. But, you know, if you designed your research question differently, you may have done all ages, you may have done both sexes together, and maybe you wouldn't have found that. So it's important to think in these kind of these rich data sets, what you can actually do in it. But you know, the agony of choice is saying, what am I actually going to do, and then seeing if you can do it. So, you know, there's lots of other related work that I could talk about just briefly, you know, in terms of time series and spatially varying data, you know, with regards to COVID, utilizing similar methods of Bayesian counterfactual forecasting, you can see, you know, in England and Wales, the actual number of deaths in the first wave of the pandemic, COVID-19, and then you can actually make a counterfactual forecast here. And then find the difference between those two to generate a measure of excess deaths. There are obviously other ways of doing it, but, you know, if you want to say account for population shift and long-term trends, this is a nice way to do it. And of course, you compare that. You can compare it over different countries, so there is an international, multinational element to that too. But I'll just go into conclusions now, I think. So really, you know, there's still a lot, I would say, to learn about climate-related exposures and how they impact health. Lots of understudied health outcomes, I would say, understudied exposures for sure, and of course combinations of those exposures and vulnerable communities, and how, you know, what we can do both to identify them and to establish what can be sort of suggested to alleviate the worst impacts. Now, of course, I just go over my work had relevance to these kind of topics, but really, if you have spatiotemporal consideration or approach to these kind of data, then there's lots of temporal scales that are possible, spatial scales, the model design is important, but also forecasting too. And that brings me to sort of the future directions with regards to, you know, just taking a step back where, you know, this is all part of my sort of K99, which I'd be very happy to talk to anyone about, that sort of award, which allows you to sort of have 5 years of transition from postdoc to assistant professor. And it's really cool. And I think, I've not seen many things like it, but it's an NIH specific thing. You don't need to be a US citizen to do it, luckily for me and many people. But, of course, climate change and health is a multi-system problem, and there's all sorts of contributions that all of us can make. Now, I've largely focused in the bottom left with epidemiology and other things here, but for those of you who are considering other things, maybe looking at cellular and molecular biology and also modeling, and all combines to the complex system. So just going back to this, deciding what to actually do with data, I think that's the day-to-day that we sort of end up with all this sort of highfalutin, exciting sort of studies and high impact in the end, fingers crossed, really at the core of it is like, what have I got and what can I do with it? And so I just sort of encourage people to sort of think with what I want to do first, because if you get bogged down in the data and then realize I actually don't know what my research question is, I think you save a lot of time there, especially with these kind of data, because these data are so powerful. You could do a lot with them. Of course, they have limits and they have sort of maybe potential to not necessarily always be perfect, but they are very powerful. Now, of course, if you're interested in sort of more specific methods, just a brief plug. I'm organizing a Bayesian modeling for environmental health workshop in August in New York City with a great team there as part of the SHARP courses. And so some of the methods relevant to what I've been showing, but also other things in environmental health, please consider checking that out if you're interested. Now, of course, thanks so much to, I couldn't have done it without all my collaborators and all my friends and family throughout the years. So especially, thank you to my current postdoc mentor, Marianthi, who this is her lab. And, I'm going to graduate from her lab in April, but I'll hopefully always be a part of it. And of course, Columbia for helping me to, fund the first few years of my postdoc with the Earth Institute Fellowship. So, I'm very happy to be staying there. But yeah, so that's it. And so thank you for your attention.
Thank you so much, Dr. Parks, for the great, wonderful presentation. We'll open it for the question. You can unmute yourself and ask your questions. If you don't have any, I can ask a few questions that have been posted in the chat box.
And I think, is it right that even after this, there's a Q&A or something that's not necessarily to do with the talk itself, right?
Yes, we have about 10 minutes for the Q&A about your presentation, and then the last half an hour till 3:30 would be for the Q&A for the early career development section. So if you have questions about early career folks, you can keep it for that part. Okay, so we don't have any question from the audience. Some of the questions that have been asked in the registration form, I'm going to combine it. So as an environmental epidemiologist, what are some of the challenges that you have to deal with within your field of research? And I know you have talked about, like data, specifically with the health data, with the zip code change, or, like ICD code changes. What other challenges have you seen in your work?
Well, I mean, that's a fantastic question. Speaking to my own sort of, I guess, trajectory is the amazing change that the computing, even when I started my PhD, which 2015, when I first started, and now the challenge really is always with models that are sort of large and spatiotemporal and have multi dimensions and things, is computing capacity and computing power, and how much that has sort of massively increased in that time. So it's a challenge, but the leaps and bounds that are being made there are amazing. And I think that's just a computing point of view. Now, with regards to the data, and I spoke at length about the possibilities for the data, but I think one thing to always keep in mind, I just want to hammer this home again, is how to treat sort of sensitive data and how to have a considered approach with that. And I would always sort of advise, erring on the side of caution a little bit, and sort of consulting with others before, any of that, if you're nervous with health data. I would say that's an issue. But of course, fundamentally, if you're dealing with climate change, even as an environmental epidemiologist, not necessarily a geoscientist or anything else, is really, these days, believability of your science in the larger framework. Now, of course, that is to do a little bit with climate change skepticism, but also, in the current era of the COVID-19 world, with preprints and things like that, that has kind of had, maybe a sort of contribution into the skepticism that people treat. So I think basically every time I release a paper, I'm very happy and relieved. But I sort of do expect that you do get a couple of emails where they do sort of ask, oh, do tropical cyclones cure hemorrhoids or something like that? It looks like your results say that. And of course you're like, no, of course they don't. But, you have to sort of interpret it in the right way. And I think that's the challenge. So, yeah.
Great. Another question is, for your study with the air pollution for PM 2.5, what model is used?
Yeah, specifically that was the cases model from Carnegie Mellon and collaborators there. So CACES. So as part of that whole funding mechanism, I think was EPA funded to generate land use regression models that need PM 2.5 surfaces that were across, I believe, the annual averages. Now, of course, they're not going to be in any way perfect, and they're going to have a contained level of uncertainty in those measurements. But one of the latest sort of cutting edge model components, which kind of feeds into the challenges that you had asked before, was really how to incorporate uncertainty of exposures into health effect estimates in these models. And I think that's a really exciting part of the next phase, if you like, of trying to sort of robustly demonstrate how bad air pollution is for our health.
Thank you. And then another question is, how do you decide which statistical model to use in your studies? Do you recommend any book resource to help orienting when making that decision?
Yeah, I mean, I would sort of look at what courses are available at university, and it's depending on how sort of minded you are with regards to maths. You might look in a biostatistics department or the environmental health department of university if you are at university. Now, for me, like I would sort of, if you're mathematically not allergic, because people may be able to do maths but don't want to do it every day, then Bayesian data analysis by Gelman is good in terms of bringing out the fundamentals, but also how you kind of use it. And then there's I use a lot of this program called R-INLA, and Marta Blangiardo of Imperial College London made this really great book about R-INLA and spatiotemporal models. I would consider having a look there. So those are, and just, I would, any of, I suppose, Antonio Gasparini's work as well with regards to, distributed lag models, and, he gives really solid descriptions, I think, with Ben Armstrong on those kind of things. So I'd have a look at those. It's off the top of my head. I'm sure there are others.
Great. Another question that we have in the chat, it says, I wonder if you could talk a little more about your ideas or plans for expanding work into less developed countries where data is relatively more limited. Where do you see remote sensing data fit into this picture for both environmental exposure and health and economic outcomes?
Yeah. I mean, what a fantastic question. I know I sort of, was saying that quite a bit in the talk, but nonetheless, it's an important question to deal with. Now, I don't have the approach that I would necessarily do a global study with regards to this. I'm not going to say I would never do it, but global study, there are lots of assumptions that maybe are just as much of a leap from as my studies, national studies or multinational studies. But global study is probably a different question because you're obviously covering the entire world, but my expertise is not necessarily in that right now. But in terms of, say, like doing an equivalent study like I did in the United States elsewhere, I think you've got to be really careful to not do what I would call helicopter research. Now, helicopter research is defined as, not having any really understanding of what the place is, and sort of, it's really, an exploitative process. You may not think you're exploiting, but it is an exploitative process. So how do you avoid that? First of all, I'm not necessarily saying I'm going to do all these studies in these different countries. I'm definitely encouraging people to think about whether these kind of studies are possible in their own countries. But if there is a partnership across countries for shared expertise and capacity, I would make sure that those people, first of all, in the countries of study are fully included and are on par with the study PIs, if you like, in maybe the United States or elsewhere. I would definitely have a mutual sharing and respective communication. But money is a big thing, so you got to be thinking about paying people on the ground to actually do the work and paying them fairly. And so, like, with sort of my nascent work in the Philippines, I'm working with partners there who are really, really fantastic. But the final thing really is to think, even if I do think this is ethical or would pass ethics or would not be subject to, human subject research, I would always err on the side of caution and at least email ethics or IRB at your university and say, this is what I'm doing. I'm just using, just to name an example out of the air, I'm just using like Google image data to try and do a machine learning algorithm on air pollution in this country that isn't my country, and I'd never been there. What do you think about that? And then maybe they would say, well, have you got local partners? Do you actually know anyone? How might this actually serve in terms of giving back information to people who are in those countries in a positive way, to avoid it being anything other than exploitative? And so all of those are thought processes that I think are important things to think about in that context.
That was a great point. Thank you. One last question before we go to the early career folks. In terms of ethical research, do you also have thoughts about communicating risks and recommendations back to the groups that are the subject of your epidemiological analysis?
Well, with mortality data, it's of course, informed consent, if you like, is not possible because they're deceased. But slight sort of silly comment aside, of course, it's important to disseminate the information back to communities. And I work with a lot of community partners, but particularly other academics who've got community work expertise in New York City, for example, and partnerships with organizations in New York City, for example, like South Bronx Unite and React, to make sure that if you're collecting data, say, you consider how it might disseminate back. So whether to do workshops or presentations and who owns the data, and to explain it, not to say, well, we published a scientific paper and here is your information. You can find it at this website. Oh yeah, but it's behind a paywall. Obviously, like the average person in a frontline community isn't necessarily going to be particularly pleased with that outcome. So you need to think about know your audience is the classic example. And how do you know your audience? Well, having people who actually understand those things, and not, for me, I would never pretend that I could understand all those things by myself. So working, again, back to collaboration, how important that is.
Great, thank you, Dr. Parks. We are on the top of the hour, and with that, I will hand it over to Francisca for the Q&A for the early career development section.
Hi, everyone. Thank you, Dr. Parks, for that excellent presentation, and I really appreciated your comments on collaboration and environmental justice and working with the community. So at this point, Dr. Parks has agreed to stay on and talk with us from the early career perspective. So my name is Francisca Landis, and I'm on the AGU GeoHealth Early Career Committee. And before we jump into that, I just also wanted to say thank you for joining us for our AGU fall meeting panel. So we had Dr. Parks and 3 others share about their career path in GeoHealth at the AGU fall meeting. And we've been told that we do have a recording from that. And once we get that, we'll be sure to put it online and share it. So it's a resource that's available for those who weren't able to join us for that event. So with that, I just wanted to maybe jump into our first question, if that works for you, and really just for, I know you mentioned briefly on the F99 and NIH fellowship, and we can go into that in more detail. But do you mind maybe sharing with us your kind of your career path, your academic career path, and how you got to where you are today?
Sure. I'm gonna, of course, Francesca. I'm gonna stop sharing my screen if that's appropriate.
Yeah, I think that'd be great.
Okay, cool. Right. So yeah. So this is a perfect example of, I think, why this is a useful exercise, because I think, you know, with assistant professors and faculty and, you know, more and more senior people, it often looks like their story was written since birth, because you look at their bios and say, oh, well, they did this thing at this great university, and then they did this thing at this other great university. So like, and then you compare yourself to that, or I did compare myself to senior people and thought, how on earth would I ever do that? So I just thought, it'd be, you know, it's good to clarify that everyone is just human, sort of scrambling around trying to find their way, as I am, and I was, you know. So I did my degree in physics, and then I took a break and sort of played music for a while, and then once that finished in London, I decided that I wanted to do a PhD in oceanography, and then got onto that in Imperial College. And then I didn't get the funding, and then my supervisor at the time, who ended up being my co-supervisor on my PhD, said, have you ever thought about public health? And I thought, well, yes, I think it's, you know, climate change is such an important thing, but I never really thought about it in terms of public health. So this was the end of 2014, beginning of 2015, and then introduced me to my PhD supervisor, Majid Azati. And, you know, I could safely say that utterly changed the trajectory of my academic career, and I'm extremely pleased at that happenstance. But, you know, to say that was more judgment than luck, I think it's really the other way around. That was more luck than judgment. However, you know, going into that, and then just really, I loved it so much, and then I took an internship at the WM, the World Meteorological Organization Joint Office for Climate and Health in Geneva with the WHO, the World Health Organization. And then I was introduced to someone who had done the Earth Institute postdoc fellowship at Columbia. And so then I decided to write a particular grant idea. And then I got to Columbia, and then I, you know, spent a few months trying to figure out what exactly I was going to do and how or not I could have done that grant application. Then I met my current postdoc mentor and friend, Marianthi Anna Kiomazulu, who's now a tenured professor in my department. And so we got working on other climate-related exposures. I'd focused largely on temperature in my PhD, and now I've expanded it really to other things. And I think I'm really, really grateful to her and that opportunity to sort of think in that way. But then, you know, at the middle of 2020, you know, obviously, you know, everyone remembers what that was like. But then I sort of thought, am I going to stay in you know, often with postdoc contracts, especially if you're not from the US, coming to the US, as soon as you get here, it feels like, you know, you have to think about leaving. And so I thought, you know, if I don't get the next step, maybe I'd have to leave. And so one of the things, because I was in a public health system, was to think about this K99 pathway to independence idea. Now, it's by no means a small thing to do to write the grant, but it is a really valuable exercise to try and understand what your research trajectory and priorities may be over the next 5 years, because it is a 5-year grant and it is a lot of resources. So I would and so I did that, and then as soon as I did that, I realized that maybe I was in a position, and it took the minimum of a year from application to actually starting that fellowship. So, and it's sometimes the average, I think, is 1.5 to 2 years to actually from starting it to getting it. And of course, it's sort of it's no cakewalk, as we'd say, but if you're really interested and you have a good idea, then I would say consider going for it. And it arms you really well going into sort of, I guess, faculty, tenure track faculty job market, because that is really, for anyone who's been through that, it's a highly stressful time. And so, but coming with funding already helped me, I think, no doubt. And so I ended up staying at Columbia. And so, so that's how I'm in front of you today.
Thank you. No, that's great. And I had seen on your bio the physics background, and so thanks for sharing. I think in this GeoHealth space, especially if you're in graduate school, you're constantly learning about new grant opportunities or conferences or different spaces where maybe there's similar work being done, but in a different department or different field entirely. So I noticed you said the meteorology or World Meteorology Organization and climate and health, and perhaps folks weren't aware that there was climate and health in that space. So
exactly, yeah, exactly. So Joy Schumacher Guillemot, who's there, and she's the chair of that department, is fantastic, and she really drove the connection between WHO and WMO there. So I would look that name up if you're interested.
Great, thank you. So we had a few questions, and I encourage anyone in the audience as well. So if you have additional questions, please write them in the chat or add them to our ask questions here, and we'll make sure that we get a chance to ask those. One of the questions that we had come in earlier was, could you talk more about your role as an agent of change and environmental justice fellow and what that work looks like?
Yeah, so Agents of Change in Environmental Justice is led by Professor Ami Zota, who's and Professor Yura Ornelas van Horn, and Max Aung and other people whose names you should look up if you're interested. But Agents of Change in Environmental Justice is really the thing that you can search for and find all those people. Now, it's a fantastic group, and what the whole purpose of it is to enable people from diverse backgrounds to be able to write and meet other peers who are sort of in their grad school / postdoc, and it stops there at postdoc, and form a cohort each year, get together in a retreat, write an essay that's personal to them, but also to do with their work. So part of the fellowship is to try and find your voice, if you like, and to form networks, and also to generate products such as the essay, a podcast, a couple of podcasts, and really just to find allies and generate ways to share expertise between different sort of interests. So I'm an environmental epidemiologist, but there are biologists, chemists, behavioral scientists, and qualitative scientists on these fellowships. And so really part of my work is to deliver those products, but also to actually I suppose highlight the fact that it really is a great opportunity to find your community, and if you want to work in environmental justice, having that resource base if you're not necessarily in any way an expert in those things, to try and, let's say, develop your expertise in collaboration with people who really know their stuff, like Amisoto and co. So it's fantastic. It lasts a year and you know, adds to your workload, but it's more than worth it, I would say. Does that answer the question?
Thank you. Yeah, no, thank you. Well, so one of the other questions that we had come in was, can you speak at all about job prospects for GeoHealth, or types of jobs perhaps that would be out in academia or outside industry? Sorry.
Sure.
Yeah. Flip that around. Outside of academia or in industry, and I noticed that, you know, there's a lot of coding that's involved, and
yeah, so of course you've got this sort of PhD translatable skills. So I mean, I won't talk about those at length, but of course you've got a lot of translatable skills with coding, etc. But in terms of like specifically environmental epidemiology or GeoHealth, if you like, or biometeorology, there's a few different names for sort of our world, but you know, there's lots. If you're interested in, you know, just transition outside in industry, there's lots of people I know who've gone from PhD to sort of working on policy and research on how, you know, the re-electrification of the United States, for example, can be done in a just way. And, you know, getting away from gas stoves and to induction or electric cookers, and how many lives that might save, etc. That sort of policy work, which, you know, from nonprofits and other similar sort of research concerns, that you can still do research in really what you're interested in environmental epidemiology, but not necessarily in the academy. I think if I wouldn't speak for my friends, but from what I can understand, it's a really fulfilling job. Now, of course, you can go into EPA. So a lot of my colleagues sort of went into EPA, and my friends, and of course, staying in academia is you know, one of those options that I think I'm not gonna sit here and say that a job in academia is guaranteed. It's not, and we can talk about all the systemic problems behind that. But what I would say is the field is growing. In my field is growing, not shrinking. And you know, the way that I see every year, apart from, you know, maybe 2020, that the multitude of jobs for tenure track assistant professors that are going out, that there are jobs being created over the country and all over the world if you're focused outside of the United States. So, you know, I wouldn't guess on how likely it is to get those jobs. But what I would say is, you know, thinking about the K99 structure for the mechanism, if you want to stay in academia, you know, is really a good thing to think about. It's not a necessary condition to have your own funding going in, but it would really help. And I think it would also be commensurate with the stage you're at to apply for postdoc / assistant professor funding. Really, you know, there aren't that many things that I can think of like that. Maybe there's stuff in NSF I don't know about, but that felt like a really good thing to be able to do. So I think there's lots of different things to do. And of course, like working in community organizations, probably what I will say is this, like, I don't think anyone's going into my field to make money. So like, if you want to be thinking about making lots of money, it's probably elsewhere, maybe in tech, or like, because of course, if you learn coding, you could, I assume you could do something in tech and other things, but I don't see a lot of people making huge amounts of money in my field, which is what it is, I suppose. Yeah.
Yeah, thank you. And because you have that great experience with the K99 and transitioning or moving from physics to environmental health, do you have any advice for folks who are maybe more on the geoscience side, of research and maybe are doing their PhD, not in an epidemiology program, but in an environmental science program, who might be interested in focusing more on health research or something like the K99?
Yeah, I would say, first of all, know your worth. And so just recognize that you are extremely valuable, whether you stay in your selected field or whether you decide to try and move more into public health and then health related research concerns. I think every day I have conversations with people about, say, exposures that, people in geosciences have so intimate understanding of, from not just a, raster level, if you like, or downloading files, but, on a physical basis. So there's a lot of interest in exposure assessment and how that obviously filters through to public health. But in terms of the practical advice, I would first of all look up K99. Then I would, email someone. You can find lists of people who've got the K99 and my name being on the NIEHS website, and then just look through what they're doing. And then if you're really interested, you could email them and say, I'd love to chat about your experiences about getting it. But also, before you do any of that, if you're at a university that has a school of public health or has public health research, just maybe look at a few names of people and see, climate related exposures in public health, and see if there's anything that might be relevant to what you do. And then think about getting in touch and discussing, maybe just a sort of, what do they call them, an informational interview, that maybe just like, oh, I'd really love 15 minutes of your time. It maybe just be a call, and just to say, this is what I've done this several times with people who are geosciences, just to say, oh, this is what I do and I'm really interested in applying it here. But, of course, having one or two actually sort of not finished interests, but specific interests, like, would really help. And then I think you'll be surprised at how often people would be super excited to try and figure something out. Now, of course, everyone's busy, but those are, where I'd start, because, in science progress today, really the progress and the biggest impact and the biggest sort of progression probably is in interdisciplinary science. And so, like, how to actually actualize that is always a challenge. But if you have a skill and you want to apply it in a public health space, then I would have little doubt in saying that would have a good reception. So yeah. And also, I have friends and colleagues who well, the thing about public health is that especially epidemiology, well, what I do, there isn't really, there are very few undergrad degrees, so everyone sort of comes. So I came from physics. I have lots of friends who came from engineering. I have other friends who came from computer science. I have other friends who came from biology. I have other friends who came from English, or like, it's really a place where people end up and bring their own value from where they came from. So I wouldn't necessarily see it as, I definitely wouldn't see it as, oh, I've done geosciences as my training, but I'm interested in public health. It's too late for me. I would say that's not true, but I would encourage you not to try and do it by yourself before you speak to people and collaborate. So.
Great, thank you. And always encouraging to hear that you see this space and the GeoHealth space and the interdisciplinary space as a space for growth, or that is growing as well now.
Of course.
So we have some questions about advice that you might have for younger students, or for folks who are doing research primarily at an undergraduate institution, or for research, if you're at a primarily undergraduate institution, as well as if you're at that undergraduate stage.
I would say if you have a primarily undergraduate institution, like a liberal arts college or something like that, and you're interested in continuing into research and grad school, I'd really think about how your dissertation could be relevant to the next step. So I would sort of really think hard maybe in your second or third year, I forget where you sort of starting to really think about what a dissertation would look like. Because, often undergrad students probably don't realize that if you do a good dissertation essay, it's probably publishable. So getting it sort of in that format, and so that is sort of something I didn't realize, but, I think if you've got the right sort of information at that age, that can really help. And, I can't speak for every single university, but, I think if you're a liberal arts college with just undergraduates, that would be something I would encourage. And what was the next part of that question? Sorry, if you're not just at undergrad, but at every other place. Could you remind me what that?
Yes, part of it was if you're doing research at a primarily undergraduate institution, and part of it was also just if you're in undergrad and you're interested in environmental epidemiology or GeoHealth, but as you mentioned, there might not be a major that necessarily is available in exactly that at
so exactly
an undergrad level.
So I would sort of do a little bit of sleuthing in maybe places in the grad elements of the faculty in those areas like environmental health, School of Public Health, and elsewhere, and just see what their interests are. And then anyone you see a particular interest in, just say, I'm really interested. You have capacity, of course, just to say, I'm really interested in, doing some work with you or for you, and trying to sort of get your foot on the ladder with what you can actually do. Because, I can speak from experience and from my colleagues that, people in faculty roles just have far too many ideas and not enough personnel. And if you've got a skill such as, I'm really good at coding and I think I can, apply a project, that you'll end up with a GitHub and an R Shiny website with data that could be expressed. Just speaking for myself, I'd be like, okay, I have this, and you can do. If you can do it, maybe, I won't speak for other academics, but hopefully you can get some payment out of it. But you want to do a good job. That already shows, from fairly early on in your grad school, that you can turn it into a sort of positive product that your interest becomes. And so I think those are a few thoughts I'd have straight away.
Sorry about that. Since you mentioned, you would have a lot of ideas. One of the questions we have is, what expectations do you have now that you're on the recruiting side, potentially, for when you're recruiting a new hire or a student or a postdoc or employee into your group?
Yeah, I mean, I think anyone who shows interest and has commitment, I think can work. Now it depends with me, and obviously there's something to do with chemistry, like the chemistry between people, whether you can work. But of course that has sort of is rooted in certain biases. So like chemistry can be worked at. And a really open understanding of what people have done and can do, and to be sort of upfront about their background, and that will help sort of people like me understand to contextualize what they've done in their past, that how much promise they would have for the future, and how that might take place is to show. So I've got loads of emails from students who are really keen to do PhDs. Now, what separates out the sort of ones that are really good from the not so sort of, no, I wouldn't say not so good. I would say people I would be excited to respond to, and people who I maybe would take a little bit longer to respond to, would be, do they have a clearly thought out sort of basis for an idea that isn't necessarily one they would be beholden to, but isn't just like, oh, I just saw that climate change was bad and I want to do something good. Like, I think for someone on the receiving end, just think about what they can contribute, or what they can sink their teeth into from what you send. Now, of course, on the far end of that is sending published papers or manuscripts of analyses you've done. But I do accept that myself included isn't always what you come into the potential to do grad school with, because I didn't even know that people had published papers from their undergrad and even the masters when I started my PhD. So that isn't an essential given, but it's definitely your prerogative to say, I would like a 15-minute informational interview. And if you think you're a person who that would benefit, to actually have a face-to-face or a Zoom call to make that person come alive, I think that's also an element too. But to turn things around slightly, you should also try and understand whether or not you want to be in this group, like, because not my group, but this group, any group that you're considering for the next 5, 6, 7 years, if you're trying to think about PhD. So how would you do that? First, we'll do a little bit of research, but also sometimes Rate My Professor has stuff. I don't think I'm on it, but other people might be. But also see if you can find and identify people who are in the group or have left the group. If you can't, maybe see how much the churn is, where people go after their PhDs who've been in that group. And I think that's really important. Like, it's not ever your fault if you're in a situation where you don't feel happy with the research environment because you joined, but as much as you can do before you take the plunge, if you like, in that research group would help. Yeah, so those are the few things I would think of.
All right, well, we are closing up here I'm on the West Coast, so 12:30 my time. So I just wanted to see if there were any other questions from the audience, or give a moment for anyone to add a question. Otherwise, I want to thank you again for taking the time to talk with us, both for the inspiring research presentation, but also giving us a little bit insight to your career path. And thanks again for joining us on that fall meeting as well. Is there any last minute, closing out inspirational comments you'd like to give us, or you're back on camera? I didn't know if do you want to close out, or?
No, I just like to say thank you, Francisca, and everyone at the GeoHealth, for organizing this. And I think, it can seem like a long road, but it can be fun. So this has been fun, and I'm grateful for that. So thank you.
Thank you so much, Dr. Parks. That was a great webinar.
Thank you, Professor. Yep.
Well, thank you so much, everyone, for being here today. And with that, we're going to end this webinar. Hope you will have a great weekend, and bye.
Thank you so much. Take care. Bye-bye.